Okay, as usual, I'm going to stop around 7:15-ish, 7:20. And then if anybody wants to stay for extending an extended one-on-one review of your work or what you have.
Okay, as usual.
Oops, so let me.
I'm going to stop around 7.
This is the live workout. Let me move this away. Okay, it's time for a quick test. This is nothing to be worried about. It's just for me to make sure that you're getting some of the basic concepts of the last 3 classes. So we're going to be very easy questions. If you paid attention during class, that's basically all is needed to be successful. So just go to the website slido.com and input the number 54650 to get started. Again, I'm going to do this here on myself. Just go to slido.com. And then when it says join as a participant, where it says enter code, you enter 5446500. And you just type it here. 5446500. You can also open your camera and point to this QR code, and it's going to launch it on your mobile devices if that's easier for you. All right, everybody ready? It's lido.com and go to the enter code. And I think it will be ask you for your name, first name, last name, and email. And you should be ready to get going. Wait, so why doesn't this start?
Yeah, it doesn't ask me about the name and email and so on.
See what's going on here. Oh, you know what? I created a new event instead of using all one. So never mind. We'll do another code. This is the one I needed. Present. So it's a different code. It's 96527. You can just start it from scratch or get out of that. And this does have code. It's slido.com and the code is 96527.
They still didn't ask name and email.
The name of the event?
Yeah. No, the actual name of our field.
Yeah. It doesn't have, you have to type it.
Okay.
Type your name and I don't think it will ask you for an email. No, it won't ask you for an email. So again, the way to do this is you go to slido.com and then in the enter code here, just put 96527. 96527, and then hit this green button, and you're gonna start joining. All right, I haven't launched the test yet, so let's go with the question number 1. And this is an easy one. What does BIM stands for? Revit is a tool that does BIM. There are many tools that do BIM. All right, I have 5 questions reported. Any more? Anyone missing?
Yeah, it's me. For some reason, when I type the number, it doesn't open anything. It's blank.
So, are you using Chrome?
Google. Yeah, Google Chrome.
Google Chrome. Okay. So in here, you
I
type
did.
96527.
Yes, correct.
96527, and then you hit this green button.
Yes. And now the only thing I have is it's like that blank with a slider.
And then it should go like this.
That's the part I don't see it.
That is so strange.
Yeah.
I don't know what to suggest.
Do you have a pop-up blocker? Maybe it's blocking the pop-up.
Oh, it might be.
Oh.
When there's a blocker, sometimes you can just hit an icon that says approve or allow.
Try one more time. Yeah, now it works. Okay.
All right. Let's see the correct answer. So building information modeling. So it's not metrics, it's not integrated. So it's building information modeling.
So I was just calling you back. I'm actually in the middle of something, but I'm just checking to see if,
Okay, let's see the next one.
Okay.
The Revit projects, the Revit models have an extension. What
I'm
extension?
sorry, I can't right now. Yeah, well, it's gonna be like till 7 or something, but if you could send me a PDF or something. Okay, thanks.
All right, I have 4 answers. I think everybody's getting it correct. It's .rvt, stands for Revit files. RFA are families or component families.
Mhm.
Those are files that we bring from outside Revit. And RTE are Revit templates.
Oh,
Okay, next one. I don't know if you see this correct on your end, but it may be the screenshot. This is the bar that is in the lower left side of Revit on the view.
yeah. Navigation map.
Yeah, it's a set of about. These are the tools that are on the lower left side of the view.
Okay. Mm.
All right, let's see the correct answer. View controls, that's correct. We use them all the time to change the properties and the visibility graphics of elements that are displayed on the view. Let's do the next one. Oh, never mind. This is I'm going to skip this. I forgot to remove the results from the last class. So, but you should know this. What's the shortcut of orbit in 3D? What do you think? Now the results are going to be misleading. The correct answer is shift mouse wheel, right? You press the mouse wheel and then you orbit around a pivot point. Okay, next one. Walls, floor, ceilings. All those are examples of A, component families, system or host families, view-specific families, or family types. Let's see, 4 responses. These specific type of families cannot be shared between projects, remember? And we usually draft them with a set of boundary lines. Yep, the right answer is system families. System families are families that can only be developed inside of a Revit project. They cannot be saved as a component. And example of those are walls, floor, ceilings. They are not view-specific families. They are not family types. Okay, next one. A collection of elements with the same properties, behaviors, and physical representation is a. Is it a category? Family, a type, as a subcategory. Okay, I see 6 results in. Let's display the results. We are almost evenly divided here.
Oh.
Let's see the right answer. Yeah, it's a family. Okay, categories are objects with similar properties, but they don't necessarily have the same physical representation. A family, it's a collection of elements that have same properties, same behaviors, and the same physical representation. An example, it's round columns. They all round columns have the same physical representation. And a type is just one element of that collection with a specific parameter value. So the right answer is family. And then a collection of types is a family, and type it has individual values. So you can think of types as the son and daughters of this family. All right, next one. On your end, you should see a larger image. And I was explaining last class that when you hover over an object, the tooltip will display information about that element. And and it display information about what that object is, how it's classified. And so what is the type name of this element based on the tooltip? Is it the roof? Is it the basic roof? Is it the generic 12? So the system of classification in Revit, it's category, family, and type. And the right answer here is I have 7 entries. The correct answer is type. It's the generic dash 12 inches. So the first portion of the tooltip disclose the category of the object. The second piece of information with divided in between those column characters is the roof. That's the family. Sorry, the basic roof of the family. And then generic 12 inches is one type of the basic roof family. So that is the type. That's the correct answer. All right, I'm gonna do a similar, I'm gonna ask the same question again next Thursday. So, because this is important, understand what's category, family, and type. So check it out. I think this is the last one. Actually, yeah, this is the last one. All right, easy. So let's go back to our data sets. In the last class, we were doing our wall playground, and we had all these different types together. And what I miss explaining is how we create a custom wall and how are the different layers inside a wall assemble organized. And so before I jump into that, let me also explain quickly something about materials. And materials is our recurrent topic. So I'm just going to cover one aspect of the materials. Because walls, everything we create in Revit is going to have a material. And this material is going to have properties that are physical, thermal. It's going to have thermal and structural acoustical properties. And it's going to have specific ways of getting represented. And so I'm going to pick, you can just open this file or create a quick wall in a brand new project. And when you select a wall, you can swap the type using the type selector. Remember, this is the type selector. And we're going to use it all the time, and we have an ability to swap between the different elements. So, by the way, you now see that I have this add-in that enable me to that will disclose the things that I type. For example, if I do WT, you will see right on the screen what's what I'm doing with my left hand. And so that's going to give you a clue that what are the steps that you need to do. For example, if I switch to a 3D view and I do the shift mouse wheel, then you'll see at the bottom of the screen what are the elements that I am typing. So you can do exactly what I do. Maybe that helps. All right, so let's go back to the level plan. And I'm going to swap this family. This family with a type that it's the exterior CMU insulated. Exterior CMU insulated. It's a new type. And if you have the DT level switched to fine, remember fine, then you're going to disclose all the internal layers and internal properties of this wall. So this wall has, I told you in the last class that this double arrow represents the exterior location of the wall. And if I've clicked that, it's going to flip it along the location line. The location line in this one, it's center line. So I'm going to create a wall section, and then I'm going to talk about the wall properties. So you click on the section tool, you can just go to the view tab and then hit the section tool. Section, and then create a section that goes from, that cuts the wall perpendicular. It doesn't matter the side, it could be the right or the left. And then open the section. To open the section, you just need to double click over the arrow in the section callout. This is a rough wall section. In the detail level, switch it to fine. And notice how Revit now displays, as well as in floor plan, all the different internal properties of the wall. So let's look at how these are organized. And before I do that, I need to quickly review the materials. So the material library, it's a collection of textures and rendering assets and material properties that ships with Revit. You're going to find it under the Manage tab. And then the first click is called Materials, the second icon from the left. And this is going to open the material library. The material browser will list all the materials that are available in this project. These materials, we didn't add them, we didn't create them. These were added to the template. And so because the template had this preloaded set of materials, then these are available to you. But templates can be expanded with the most frequently used materials. So if you are an interior firm and you use a lot different type of partitions or ceilings, then you can add that information inside the template and save your users the need to add or create additional materials. But let's look at very quickly the identity and the graphics. When we get into renderings, I'm going to talk more about the appearance. Materials in Revit have a list of metadata that describe what that object is, what the material is. For example, when I select the acoustic ceiling tile, it gives me the name, the description, it gives me a class. Class is a way to classify objects, classify materials based on its use. And you have also the ability to add and include additional metadata. Interior designers use this metadata to create their interior finish schedules, for example. Over here by the top, there's a bar that's called search. And in here, you can type keywords associated with the material name. I'm going to type concrete. And notice these are the type of concretes that are filtered out in this panel. And I'm going to select the concrete precast. Now look at the graphic tab. And the graphic tab have the graphical standards associated with the material. And this include how the material is going to display in shading mode. Shading mode, it's a graphic display that you switch using the graphic overrides. Remember when we switched to heathen or shaded or rendering mode, this is the color that the material is going to display. Now shading, it's a property that is only visible in 3D. And for the most part is not embedded, is not something that's going to get printed. Then we have the surface patterns and the cut patterns. Surface pattern, it's the hatch that's associated with the material and when it's displayed in projection. And 3 years ago, we added foreground and background patterns, meaning that at the foreground, you can have one texture, and in the background, you can add a color. For example, if I want the concrete to display always a solid field that is gray, that's something that you can change in the graphic portion of the material. Also, in the cut pattern is how the object's going to be represented when it's cut by a view plane or the work plane of a view. You have a foreground and a background texture. This is these are the global setting of this particular material. You can always duplicate it. If you right-click on a material and duplicate it, you can make changes to a copy of the material. But for now, know that every material has the potential to be represented with a specific pattern, both in at the surface pattern and the cut pattern. I don't want to change this, so I'm just going to cancel this. And now that we're going to start looking at materials embedded inside a wall, let's look at the wall properties. So,
Cesar,
yes.
do the levels 1 and 2 pop up automatically because I don't see them?
They do pop automatically, and that is because they should open automatically if they are turned off. And are you using last week's data sets?
Yes.
If they don't show up, try highlighting this reveal hidden elements and see if it's there. No?
Nope.
The other thing that might have happened is that this wall, it's outside of the levels. No, it should be there. Like if I move this wall like far out. Let's see a section. Yeah, they always show. It's strange.
Okay, that's fine.
Yeah,
I'll
it's
try
not
again.
it's not relevant right now. But
Yeah.
maybe we can look at it at the end.
Okay, thanks.
Yeah. Okay, so in the property, when you select an object, it's going to display the property. The property window is going to display the property of that object. And this particular one, it's something we need to remember. The edit type button here, it's called the type properties. Type properties. It's this. It's going to disclose the properties associated with every wall that is of the same type. And the type properties of the wall has a parameter called structure with an edit button that's going to display the internal layering system of this assemble. And so this is this dialog box provide you information about the family. What is the name of the family? What is the name of the type? This is the total thickness, thermal and resistance information. And every row represents a layer. A layer has a function, has a material, and it has a thickness. You also have the ability to highlight which is the material that carry the structural properties. There are two layers that are not technically materials, but they are just dividers. And these, the core, all the elements in between the core, all these materials here, that represent the core of the building. So remember last class when we were creating walls and we were defining the location line, one of the options of the location line is whether you place a wall using the core interior or the core exterior. And what that means is that the location line is going to be associated with these boundaries. So the wall is defined from the exterior side to the interior side. So start with a structural layer. So I think this is, in this wall, this is the exterior and this is the interior. So it has a masonry wall, then a thermal layer that's 2 inches, radiant insulation that is 3 inches. Membrane layers are always 0 thickness because they are paper based, but they do have a material and they do impact how a wall perform. And then it has another structural concrete masonry unit wall. That is what's considered the core, everything that is in between row number 1 and row number 7. And then it has a substrate, metal furring, and it has a finish that it's a wall board. The order of these rows can be manipulated using the up and down button. So you can just select one of the rows and move it up and down. And so you also have this button called preview. And this preview, it's a plan section from the exterior side of the wall to the interior side of the wall. And it will display exactly the same information. This is this layer, that's this layer. A paper thin membrane layer that doesn't have any thickness, and the concrete masonry wall. And so from here to here, that is considered the core, because it's everything that is between row number 1 and row number 7. And you can move the core, you can move it up, you can move it down as needed. And then the remaining layers, those are finishes. And so there's a substrate layer, and then there's a finish layer right at the bottom. And that's how a wall it's built. When we create a new wall from scratch, we have to assign a function, a material, and a thickness. We look at the materials, and if a material doesn't have any material, if I just call it default, or if I do not assign any material, the wall is going to inherit the properties that are set in object styles. Remember object styles yesterday, which are the global properties of Revit objects. And so if I do not assign any material, it's going to inherit that property. Thicknesses, they all need to be greater than 0, except membrane layers. Membrane layers are always going to be 0. In fact, if you change this to something else and keep it as a membrane layer, then Revit's going to get angry. Says membrane layers cannot have thicknesses that are greater than 0. So function of membrane layers always 0, or Revit gets angry. These core boundaries is not technically a material, like I say. These are just, you see the green lines here. This is just a delimiter, delimiter. All right, and then the functions, and functions is something important to understand. Functions are, let me pull my slide deck, maybe that helps better. Okay, a function, it's define the performance use of a material, but it also has in brackets a number, and that number is called a priority number. And a priority number is a method used by Revit to understand how materials connect in wall intersections. Elements of the same priority with the same material are going to neatly connect in a clean layer at wall intersections. Elements with the similar priorities are just going to abut to each other. And and here's an example where you have two walls of the similar type. Elements belonging to the structural use, which have priority number 1, abut the CMU core of the other wall. These two have a structural use, but because they have the similar materials, they don't merge. So you just see this abutting line between them. Look at the brick priority 5 in this end and the brick in this end. These two walls share a finish layer with priority number 5. And because they both have the same material, they merge very cleanly in a corner. Let's see this layer. This is the airspace priority number 3. And on this wall, this is an insulation priority number 3. They have the same use, which is thermal properties layer, but they have the similar material. And so airspace doesn't have any material. The insulation layer here does have a material. They both belong to priority number 3, and the layers abut to each other. And so the purpose of the priority number, and this is on exam next Thursday, is to enable Revit to manage the layer connection at wall intersections. Sometimes it mirrors exactly what happens in construction. Sometimes we have to modify it manually, but we're gonna get there when we get into details. All right, so let's build a new wall from scratch. So I'm gonna cancel here. And when we create a new wall from scratch, and hopefully you don't have to do this, hopefully all your typical partitions have already been created by your BIM manager. And all you have to do is open the template, and those wall types will be available for you with all the metadata needed to schedule it and document correctly the project. But if you have to create one from scratch, I would recommend to start with a generic one. So this is our generic wall, the 6 inches, doesn't have any layering information, it doesn't have any material. And so let's see, we're gonna create a special type of G-port wall. Maybe it has 2 layers on one side and 1 layer in the other side. And 3/5/8. 3/5/8 studs. So we're gonna edit the type. I'm gonna show you now, this is the process of create new types based on an existing one. And we're gonna do this really often in Revit when we create new content based on an existing one. So there are 3 steps to do this. Step number 1, duplicate a type. We're not going to start anything from scratch. We're always going to pick it up from something. Then we're going to rename, give it a new name. And then step number 3, change parameters. So you change parameter values, and then you have a completely new type based on an existing one. All right, we're going to do this process over and over in our class. So let's remember this. Okay, I select this wall, edit the type. Then I'm going to duplicate it. And I need to pick a name. The name of the partitions, usually it's something that is standardized inside companies. Different companies have different standards in the way they name their partitions. I work in firms where they have a very specific numerical sequence, you know, like A, 1, B, 2, and each of them has a metadata reference to a system of classifications. But in this case, I'm just going to go a bit easy, and I'm just going to call it custom jib board wall. Custom jib board wall. That's the name of the type. So this is step number 2. The first step here, duplicate. Second step, give it a name. And now that I have a new type, I edit the structure. Now, what happens if I don't duplicate? And this is very dangerous. If I don't duplicate a type and I go straight into edit the structure information, then I will be modifying a type that it's in the project and potentially in use in parts of the model. So if I change the type properties of an existing type, it's going to modify all the entities that in the model that are currently using this type. So we need to be careful about making the right decision of changing a new copy of type. All right, so with this new copy, I can access the structural properties. And notice that this is very simple. And what I was saying earlier, if I don't give any material, the material of this structural layer is going to be by category according to the object styles. So I know that the steel is going to be 3/5/8 and it's going to have a metal stud material. So let's start with fixing the thickness. It's 0, 3, 5/8. That's the thickness. The function is 1. Look at all the different options. So there is a structure, substrate, thermal, finish 2, and member layer, and then there's a number in brackets, this priority number. And remember, the purpose of the priority number is to make sure that the elements connect correctly in wall intersection. And then in the material, I'm just going to click inside the cell. And there's right at the cell, there's 3 little buttons that launch the material library. And inside here, I'm going to look for the metal stud. So you just type in the cell search, just search for stud. And there's a metal stud layer, which doesn't have many properties, but they do have the appropriate physical and thermal properties. It has a steel assets, have thermal assets. So I'm just going to leave it, just select the metal stud layer, hit OK. and I have a wall with a metal stud layer. Okay, so in the interior side is gonna have one layer of G-board that's 1/2 inch. And then on the interior side is gonna have 2 layers of G-board 3/5/8. So the core is not a material. These are just line delimiters that define what's the core inside a wall. So to add a new material, you just select a row and hit the insert button. And that's going to add a new row above that button. And so because all of these are Gboard materials, I'm going to add all the layers now, and then I'm going to fix the materials later. There's one layer in the exterior side and 2 layers in the interior side. So I'm going to select row number 4, and I'm going to add 2 layers, 1, 2. And then using the up and down buttons, I'm just going to move them away from the core. So the Gboard plates are not structural. So just hit the down button to move them away from the core. I'm going to select the other as well, away from the core. And I think now I'm going to fix these thicknesses. So on the exterior side, I'm going to pick a function that it's finish 1. I'm going to add a thickness that is 1/2 inch. And I can pick a material that is Gboard. And in the material browser, just type gypsum wallboard. It comes preloaded with cut patterns and surface patterns. And I have now my 1/2 inch Gboard and the exterior side defined. I need to repeat the same for the other ones. If elements have the same material, I typically use the same function. If they have the similar materials, I would pick finish 2. And these are going to be 5/8 of an inch. And both of them are going to be 5/8. So I'll do this also finish 1. And then the material I can open the material library and assign it. But if I want to go easy, you just hit on the, if this material has already been loaded in another cell, just hit Control-C, copy the text of the material above, and then paste it, Control-V. That way you don't have to go and browse the same material multiple times. So the total thickness of this wall is 5/3/8. Notice how in the preview there are these green lines. Those green lines represent the cores. So it's the area between those green lines are the core elements of a wall. All right, so now that I have this, I can hit OK here and start over, and I will have my new type. During the process, don't hit cancel, because you cancel is going to erase everything. All your work is going to disappear. You have to do it again. So hit OK here, hit OK. And I have this nice wall in section that has the right properties. Now we usually associate tags to walls, and this class I'm not dictating you, or I don't establish what the company standard needs to be, but embedded in the wall you can have type identifications or mark identifications that will allow you to tag things. And so let's say this particular wall let's call it 3A3B. That's a convention. And so A3B is going to be embedded in the metadata of the type properties. So select the wall, edit the type, and then scroll down where it says identity data, where it says type mark. And here I'm going to do 3. And it's going to be A to B. And how you label interior walls, it's a company standard. You apply it here, and then here, okay. Again, select the wall, edit the type, scroll on the type properties, find the type mark, and type 3A to B. And now to mark this up, you can, to tag it, just go to the Annotate tab, tag by category, and select the wall. And you see how it will tag it in a section. You can also do it in a floor plan. So on level 1, I can go tag it. And notice that all these other walls that I have, they don't have type information embedded. These are generic walls. And it displays as empty. So I edit the type and I change this to something else. Then I change the type properties for all the walls of the same type. And that information is now reported via tags. And this is what you do in a construction plan. You disclose information about the type, the wall type, and embed it into the tag. If the property changed, the tag gets updated automatically. I look, for example, if I select this one, and then we later decide, oh, you know, this is mislabeled. Let's just change it to 3A to C. Just change it here. And now the label gets updated as well. All right, this is the process of creating a new interior wall from scratch. I see a question here from Ruth. What is wraps? That's a good question. When I edit the type properties and I go into the edit structure, notice how there is a column called wraps and another column that it says the folder wrapping at inserts and ends. So wrap, this checkbox enable the layer ability to display itself in the end caps. And if I enable this, if this is enabled, then I have access to these two buttons. One is a display wrap layer. If you say at the ends, exterior or interior, what that means is that if I say interior, the interior layers wrap towards the exterior. If I change this to exterior, then the exterior layer wraps into the interior. Again, this behavior is only going to be enabled if this checkbox is on. If this checkbox is off, notice how the wrap disappears. So the other is this at, oh, I think I have a slide for that. Here's wrapping, what wrapping means. When it comes to an insert in a wall, it's a wall hosted element like a door or a window. In this case, we have a window, and then the property that controls how the materials turn at those insert, it's something that you define in this Revit dialog box. So in this case where it says an insert, you can say, just move the exterior layer towards the window and stop there. Or move the interior layers into the window, or do both. Both is the most common. Both means that both the interior and the exterior wrap around the core element of the window. It's a type property, not a lot of people use it. So this is not usually defined unless there is a very specific aesthetic. So I would recommend if you use wraps, maybe you create a different type and you add a descriptor that says this is a wall that wraps, so that not all the walls have that
I'm
behavior.
sorry. I have a little more.
I'm
left.
fine.
Yeah, I can give you more. You
I'm
only
fine.
had a little bit. Okay.
Thank you.
All right, I'm going to leave it as do not wrap at the end, but that is to answer your question, Ruth, a long answer. Okay, there are other properties, and we're going to come back to them as well, like this vertical structure information. We're going to get there shortly. But this is how we add metadata into walls, and this is how we construct one from scratch. Again, these are company standards. I don't recommend you to start building your own. Check with your BIM manager. These type of families cannot be saved as new components because they are system families. You know, when you edit the type, notice how walls have this word system as part of the family description. And that means that you cannot save it as a file. But you can copy paste them. That's the good news. So if you have a set of walls in a project and you want to recycle them in another project, you can just copy paste it. I'm going to create you don't have to do this, but I'm going to create a new project from scratch. And I'm going to say, okay, I'm going to capture this wall type from this project I have. Copy to the clipboard. Copy, you can also Control-C. And then switch to the new model and paste, Control-V. And when you paste it, the definition is brought into Revit. It has the same properties from the previous one. And I can also tag it. It has all the properties of the previous project. And so system families, although they cannot be saved as RFA, you can copy paste them between projects. And that's true for floors and ceilings and window and roofs. All right, I'm going to close this file. Is it clear how to create custom walls? There's also another rule that I forgot to mention, and it's an important one. And that is that the priority number grows from the core to the finishes in a numerically incrementally. I'm going to type it here because this is an important concept. Priority numbers grow from the core, and the core is going to be priority number 1 to the finishes, which is priority number 4 and 5. And they have to be incremental. What does that mean? That means that I cannot randomly assign functions out of order. the priority number grows from 1, which is at the core, incrementally to the finishes. So I can have 1, 2, 3, 4, 5. But I cannot do like 1, 2, 1, 5. Revit is gonna get angry. For example, let's say I do this finish as number 5, and then I switch this to substrate. So I'm breaking the rule here. I started from the core at 1, and then I go to finish and substrate. When I do this, Revit gets angry. It says, the layer function cannot grow from the core finishes to the boundary face. So I need to go back and fix this. Gboard, it's a finish. They can be the same number. For example, you can do 4, 4, that's gonna work. But you cannot put them randomly out of order. It has to follow that rule. And then the finishes, the functions are important because, especially in Revit 2022, consultants have the ability to strip the finishes out of their walls. And this is useful for structural engineers who only want to focus on the effect of the structure in their analysis. And so in Revit 2022, you can just display the core boundary in walls. You cannot do this in 2021. So that's a new feature. And you strip the information from elements that are not relevant for the type of analysis you're doing. All right, any question here? Is it clear how to create a new wall from an existing one? The 3 rules: duplicate, rename, change parameter value, and then you create more elaborate wall types as needed. Okay. Let's do an exercise. I'm going to display a wall section, and I'm going to give you maybe until, I don't know, 5 minutes to create it from scratch. So let me find that here. Okay, do you see this diagram? Ignore right now the revealed brick and the sealed precast, and just construct the following wall type on your own. It's 640 right now. Let's finish at 645. So I'm going to leave it in the screen. I'm going to do it myself as well. Again, forget about these precast and the bricks, but just create this. This is the exterior, and this is the interior.
So start from a scratch, basic, whatever, 12-inch, and then just build it.
Yeah, the generic.
Generic. Yep.
And you can call this, yeah, just call it brick on CMU. That's the type of wall, brick on CMU. And when I did this diagram, notice how I didn't point the leaders exactly to the right material. So the 4-inch brick is the is the one at the outside. I think this needs to be just move a little bit. Ignore the precasts and the reels. So I called out the drywall. The material is G-board, right? The same thing. Also for CMU, you will find a concrete masonry unit as a material. And for the channels, that's a metal stud. That will be a material. Okay. If you're stumbling, I'm gonna put the solution here on the screen. We add additional layers using the insert button. And then we work on the different layers from, oh, I did it incorrectly. I started from the exterior to the interior instead of the opposite. So one thing I'm going to do to fix this I'm just going to move this all up. I want to move the surf straight down. Finish it down. And then move this up. Okay. Goes from the exterior to the interior. And I started with the brick. The brick layer is on the exterior side. In this particular example, it's just a finish. It doesn't play a structural, it doesn't carry any weight for the analytical purposes. We have thermal layer is the air, rigid insulation, 2 inches. Then comes the core boundary, with that the green line is. Then we have the structure, the substrate, and the finish. Materials, you just search for what is. You're not going to find exactly the same wording for the materials, so you just look for what's approximate. For example, you're not going to find a for the support layer or the dry hat layer. You're not going to find a hat layer material, so I just search for whatever is closest in the material. The metal stud layer, it's appropriate. So that is an 1.5 inches. And then the finish, 1/2 inch U-board. All right, if you could just maybe let me know if you finished, then we will continue. I'll be back in 1 minute. 1 second. All right, are we all good? All good, all right. You can do a screenshot if you want to do it yourself later or watch the recording. Okay, this is how we create custom walls. Now let's any question about this? Fairly straightforward, right? Okay. We're going to start now the discussion of grids, levels, and columns. And we maybe just going to be able to create levels and grids. We may not get into the columns. We'll see. But let's close this file. You can just save it. We're not going to use it again. I'm just going to save it. You don't have to do this. I just want to give you a quick overview of what levels is. And then we are going to start one from scratch. Starting in Revit 2021, we have the ability to display grids in the 3D view. Where are they? Or maybe not. I thought they were here. Yeah, they're there. These are the levels. So levels are horizontal work planes that are typically associated with the finished floor of every floor. Levels host everything we place on the views. When we place furniture, when we place toilets, when we place walls, they are all associated with the level that it's part of the view. Levels also define the start and the end of a lot of different elements. Levels, for example, define the bottom height of a wall, the top height of a wall, and levels are they have a dimension. When I select a level in 3D, it has a length and a depth, and it's when we craft elevations, what you see in an elevation is actually a projection of that level. See, for example, this is an elevation and this is a level. Notice I'm going to tile this into WT. When I select a level in 3D, I'm also selecting it in the elevation. That's the ground level. This is the second level. This is the third level, the roof and the parapet. So when we start a project, one of the first things we need to do is to enable levels and grids. So we're going to start one from scratch. So I'm going to close this and let's create a new model from scratch. Just hit the new button and select the architectural template in this drop-down list. New architectural template. And just by looking at this view, I immediately noticed that this template comes with two levels. You see it directly here in the project browser. Here, our floor plans associated with two levels, our ceiling plans associated with two levels. And just by looking at the project browser, I know that this project has two levels. You can also open the south elevation and notice that there is a level 1 and there's also a level 2. These levels were part of the template. I didn't create them. So I'm gonna also open the west elevation. And these are three different views looking at the same thing. Remember, I tiled this, zoom WT, enable me to tile things in a view. And then zoom all, it just zoom all the views to the full extent. And so also, I'm also going to open a 3D view, maybe close, yeah. I'm just gonna make the 3D view float here on the side. This is level 1. This is level 2. And let's look at some properties of the grids, of the levels. The level, it's a category. The name of the family is level. It's right here. This is the family, remember? This piece of information and the type selector is the family. The second piece of information below is the type. So this is the type name. This is the category. This is the family. Levels report elevation heights. You can just manipulate it directly on the screen. So you can just hit on the 10 feet and increase this to 15. Levels have a annotation mark that can be switched on and off. If you click this checkbox here, enable you to display or not display the elevation marker. You can also do that in the opposite end. In the opposite end of the level, there is a checkbox. If you prefer to see them on the left side, this is how you do it. If you prefer the levels to be seen on the right side, then just disable these and enable them on the right side. Also, levels love to align automatically. So notice here how I have this dash line. And this dash line is connected to an empty circle in the lower level. If you drag that circle towards the right, notice how I am decreasing and increasing the size of the level projections. And you can see it in 3D right here. I am stretching the levels, and you can see how the projection of the levels, it's also stretched accordingly across all the different levels. And so this little lock is just a visual indication that there's a alignment constraint established between these two levels, and this is a default behavior of all levels. You can create new levels using the pick line tool, which is the easy way of creating a new one, or you can create one from scratch. Revit loves to remember the names of the last thing created. So in this template, I had level 1 and level 2. They were already created for me. So the next time I create a level, it's going to be named level 3. Revit has good memory. So to create a new level, you just go right at the far end of the architectural tab. It's right here, grids tool. And these are the different methods of creating levels using 2 lines and using the pick line tools. I'm going to use the first one first. The first method, you have to click in the, I'm going to do it on the west elevation. So I'm going to click, this is my first point. This is my second point. Oh, the grids. Oh, I'm so stupid. It needs to be levels. Architecture levels. Levels. And I'm in the west elevation. So I create my first click. Then I create my second click. Now notice something really important here. As I create a plan, the options bar gives me a checkbox that says create a plan view. This is by default. And what this means is that when I create this new level, a new floor plan is going to be added as a floor plan and a ceiling plan. If you deselect that, then there's not going to be plans created for it. So I hit my second click here and notice that as I create the level, you can see snap through the extension. And you can see in 3D how it was created. And Revit remember the next sequence in the level convention, so it named it as level 3. And in the project browser, now I have a floor plan level 3 and a ceiling plan level 3. And notice in 3D, because this level is a little short, how the projection, it's also short across all the views in the west and the south. If I stretch the endpoint of this grid and move it to snap to the extension to the end, you're gonna feel it. It's almost, you can feel it as snaps. And then now you have your level 3 created on the screen. If you delete a level, you can delete a level by just selecting it and make it delete. But when you delete a level, be careful, because it's also telling you that all the views associated with the level are going to disappear. So there's going to be 6 different views that are going to be deleted. And you just say, okay, here. And now level 3 is not part of the project browser anymore. The other way of creating levels is using the pick line tools. Let's do that. So you go to level tool and use the pick line tool. And this, instead of selecting 2 lines, we're going to create a new level using another level as a reference and an offset value. So I'm going to set my offset value to 15. You can just type 15 in this offset cell. And then I'm going to carefully hover over level. And I want you to notice exactly the preview of the level. Because when you see a preview coming above level 2, that's where you click. But what could happen very easily as well is notice how the dashed line is now below. In this case, I'm going to have 2 levels on top of each other. So this is a little subtle. When you create a new level, you have to watch the preview to confirm the location of the level. So hover over level, click, and now you create level 4, because Revit always remember the last sequence. And if I need to change this, just overwrite it, call it numbers level 3, and rename it. You cannot have levels have the same nomenclature. If I try to call this level 2, for example, you can just type on top of it to change it. Revit's gonna get angry and it says, sorry, but levels can only have one name. And that makes sense, right? You don't want to have redundant views that confuse your documentation. To move the height of the level, you can just type the height directly here. And I'm going to lower it to, let's say, 18 feet. When 2 levels are like too close to each other and then they start overlapping, let's say, for example, this is 16. These 2 levels are just too close to each other. In documentation, this doesn't read very well. And so one thing you can do is to enable this arm and elbow. It's an annotation that will allow you to increase or decrease the location of the level name and number. So the first grip manipulates the arm extension. The second one manipulates the elbow extension. Again, I'm going to do it again. If you have 2 levels that are very close to each other, select one of them, and I want to select the level 3. And right in the middle of the level, there is a symbol that looks like this. It's a break line. What this does, it creates an arm and an elbow. The first grip is the extension of the arm. And the second grip raises the elbow up or down. And so you don't have to, you can have these two levels really close to each other, but they will displace. And this is a view specific setting. Notice in the south elevation that I don't have that. I don't have that established. When I do this kind of changes, it's at a view specific level because these different views can have different scales. And so they may or may not have the same need of clearing the elevation marker. What else? Yeah, let's create a sequence of levels for a building that is 5-story high. So I'm going to change the elevation back to 30 feet. And to straighten this out or move it the way it was before, just grab the second grip and snap it to a horizontal point or horizontal point and release. The elbow is going to heel, is going to align with the horizontal plane. Oh, I know another thing that's important. So notice also how inside this there is something called 3D. And so a 3D view, it's visual indication that the projection of the level, it's in alignment with the level extent. This is the level extent. And so there is a global correlation between the projection. And let's see, this is the west, north, south, east, west. So this is the west side. So the size of this projection is exactly the size of this projection. It's 3D. What that means is that there's a three-dimensional coordination with the global size of the working plane. But why is that important? Well, one of the properties of the views is this crop view. A crop view, it's right here where it says extent. And a crop view is equivalent as the viewport. So it's a window into the 3D space. Again, just make sure you have nothing selected, and in the property window, enable the crop view and the crop region visible. And so when the crop region, it's small, when I change the size of the crop region, notice how the levels also change in size. And when I select a level, I no longer have something called 3D, but I have something called 2D. And what that means is that the projection of the level for this view has been cropped for this specific view. So only this view display the level at a shorter display. And it's 2D because it's view specific and is now disconnected from the projection at the 3D level. Does that make sense? And notice how when I select this level, I still have these white grips here. And that white grips is a visual projection of the full extent of the level. So to return this to a coordinated size, just disable the crop views. And then when you select the views, notice how they turn back to 3D. And so it's it's a way to override the projection of the level at a specific view. Okay, any question? All right, let's create levels using the pick line method, and we're going to create a 5 levels, 15 foot apart, level 1 to level 5, and then we're going to create a parapet that is 6 foot above the roof level. So we have 3 levels created already. I'm going to create 2 more using the pick line method, and this should be super easy. You go to Architecture tab, Level. You use the pick line tool, is the arrow over the green line, and then select an offset of 15 feet. Hover over the level and make sure the preview line is above the level, and then hit the left click. That's level 4. The command is still active, and it's still going to offset another one at 15. So I'm going to do another one at 15. That's level 5. And then I'm going to stop here using Scapescape. So you have levels from 1 to 5, 15 foot apart. And lastly, what I'm going to do is to create a parapet level. And I'm going to use the copy command. All the modifiers of elements are under the modify button, the modify tab in the upper right side. So these are the different modifiers. We're going to use them in the modeling process a lot. This is the move command. The shortcut also is MB. This is the copy command. The copy command, the shortcut is CC. This is the rotate command. The shortcut is RO. So you can just type this on the fly and it will activate the command. There are other ones like the offset, 2 method of mirroring by drafting the mirror line, mirror by picking the axis of reflection. This is the align button, and this is another one good one. This is the trim to corner, which is equivalent to the fillet. So when you have walls and you want to connect them into a corner, don't use the command trim fillet, but use the trim command. It's the trim, and this is the extent. These 2 are the extent, delete, and pin. I'll come back to the other ones shortly, but right now, move, copy, rotate. Those are the popular modifiers. So to copy, to create a copy of something, and this, I think this is different from AutoCAD. In AutoCAD, we invoke the command, and then AutoCAD prompts you to select the object. In Revit, 80% of the commands, you start by selecting the object and then deciding what to do with that object. So it's object specific instead of action specific. So you select the grid and then decide what to do with that grid. I want to copy this grid. And the modifiers are going to be available to you in the modify tab. So you select the level, you're in the modify levels, and then you use the copy. And the copy command forces you to pick a handle and then a destination. A handle point, it's a point in the object. You're going to start the copy. And then the destination is the point towards you make the copy. So when this hits 6 foot, or you can just type on the fly 6, then that creates a copy of the level. Now, notice that there's a difference between these 2, the color, right? So this level is blue, this level is black. And when you copy a level, you disable the ability of the level to create new views. And so notice how I have floor plans here, ceiling plans, but I don't have a floor plan of level 6 because I copy it. So this is a Revit behavior. When you copy a level, it will not create a plan for you. And this is useful. Sometimes you have a parapet level that is just for reference, but you don't have like a parapet plan. You resolve that at the roof level. And so I can convert a reference level into a floor plan. To do that, you go to the View tab, and then you create a plan view, create a floor plan. Again, View tab, Plan View, Floor Plan. And this is the list of levels in the project that are not associated with a floor plan. The only one I have is level 6. When I do this, and look at the west elevation, noting now this is blue. And if you look at my floor, now I have level 6 here, therefore this is blue. Now I can reverse it. I can convert a level from view reference to just a reference level. So if I select level 6 in the floor plan and delete it, then my level turned black again. There's no floor plan associated with level 6. This is a reference level. So in a nutshell, these are levels with views, and these are when they are black, they are levels, reference level, no views. And I show you the process of converting a reference level into a view. Just go to Plan View, Floor Plan. Okay, I'm going to leave this 6 foot above level 6, and these are all my levels. And let's save this project. I'm going to call this project my first building. And make sure you save it in a place you can retrieve next class, because in the next 4 classes, we're going to be using this data set. I'm going to call this my project. One thing I need to notice also, when you keep saving a file on top of each other, Revit always make a backup copy of a historical file. So when you save a file, the original file, it's copied with an extension number in case you want to retrieve the old copy. You can delete the ones that have numbers. It's not needed unless you want to have it's like a number stamp in case you want to retrieve an older file. So I'm going to call it my first building, my first building. Then I'm going to save this. And we should have 6 levels from level 1 to level 5. Oh, let's rename level 5 and call it roof level. When you rename a level, Revit is going to prompt you to rename the views as well. So when it asks you to rename the views, you can say yes. And then level 5 is not renamed as roof level. Then the other thing to notice is that under the views, you have structural plans. We don't craft structural plans. So all these structural plans were created automatically. Let's delete them. And you can delete the views just by right-click, delete. No structural plan, only floor plans and ceiling plans. Okay, so it's 7:20. Next class, I'm going to show you how to create grids and columns and floors We are just slightly behind, but next class, be prepared because we're going to do a lot of modeling. We're going to do the floors, which is a system family. I'm going to show you the properties of doing sketch lines. See what else is for next class. Oh, and we are going to load components and families. Column is a component. I'm going to show you how to do that. All right, save the file. We're going to retrieve it next time. I'm going to now